Hello, pals. Today we're going to be looking at another phase on surd. Now, we've been on surd for quite some time and we've covered a couple of things on it. Now, we're going to be looking at the last phase on this very series called surd. In our previous exposition or lesson, we worked on how to get the square root of surd. So today we're going to be looking at equations of surd. We're going to be looking at various equations involving surd, irrational surd. So before we go directly into today's lesson, I want to tell you something. It's very important for you to have a basic knowledge of quadratic equation. If you don't really understand how to solve quadratic equation, you find it very hard for you to understand what you're about to take. And also not just quadratic equation, also you need a basic knowledge of simple algebra. And apart from that, you also need the basic knowledge of probably trinomial equation or a little bit of polynomial equation. Now, immediately we conclude this very exposition, we are going to be working on all kinds of equations. So quickly, let's see what we have for today. Now, look at this question. Solve for x. Now, in this is an equation. Solve for x. That's root x plus 7 minus root x plus 2 equals to 1. Now, you also need a basic understanding of indices. We're going to be working on all that in the next couple of expositions, but you need to know them at least to an extent for now before we go into this. So how do we solve for x? Root x plus 7 minus root x plus 2 equals to 1. What's the value of x? Now, it's very simple. We just have to, you have to collect our like terms. This is what we're going to do. Just watch. This root x plus 7 minus root x plus 2 equals to 1. I can decide to send this one to this side while this one stays here, or I can send this to this side. I can send this to this side and send this to this side. So whichever way you want to go about it. So x plus 7 stays here while this crosses to the other side. This is 1 plus s plus 2. Now this is an equation because of the fact that we have an equality sign. This equality sign means everything here is equals to everything here. That's how we call it equation. So s plus 7 in root equals to 1 plus root s plus 2. This one moves to the side to come and meet this one. So what do we do? The next target is for us to take off the root. How do we get rid of the root here? So that will be x plus 7. The knowledge of indices is very important. Raised by 1 over 2. These are root here. The root has become this 1 over 2 here. The 1 plus root x plus 2. Now we have to look for a way to neutralize or to remove this very root here, this 1 over 2, the power. So that will be times 2 over 1. We're going to use our multiplicative inverse. Now whatever you do to this place, you have to repeat it here in order for you to maintain this as an equation. If not, it won't be an equation anymore. Times 2 over 1. 2 takes out 2. What do we have? We have x plus 7. Just raised by 1. That's it. The 1 plus s plus 2 raised to power 2. So we're going to expand this. That will be s plus 7 right here. 1 plus root s plus 2, I beg your pardon. Then we repeat it again. 1 plus root s plus 2. So we're expanding right away. So that will be x plus 7 equals to. So 1 times 1 is 1. 1 times root x plus 2 will give us root s plus 2. So plus root s plus 2 times 1. That will give us plus root s plus 2. So plus root s plus 2 times plus root s plus 2. Now you need the basic knowledge of indices, very important here. If we are given root s plus 2 times root s plus 2, what does that mean? It means s plus 2 raised power 1 over 2, which is the root, times s plus 2 raised power 1 over 2. Now whenever the bases are the same, as you can see, the bases are the same and the powers are also the same. But let's look at it from this angle. Whenever the bases are the same, under the product rule for indices, you pick one of the bases, multiplication becomes addition. So you pick s plus 2 here in bracket. This becomes addition. That will be 1 over 2 plus 1 over 2. That will be s plus 2. 1 over 2 plus 1 over 2 is 1. So it's s plus 2. So what do we have? Root s plus 2 times root s plus 2. Plus and plus is plus. S plus 2 in root times s plus 2 in root will give us just s plus 2. So we have this already. So we're going to carry on with that. We bring them down like this. What do we have here? This x plus 7 equals to 1 plus root s plus 2 plus root s plus 2 will give us 2 root s plus 2, then plus x plus 2. What do we do next? We carry on x plus 7 equals to, we can collect our like terms. 1 and 2 can come together, that's 1 plus 2 plus x plus 2 root x plus 2. So we continue from here. Here will be x plus 7. 1 plus 2 is 3 plus x plus 2 root x plus 2. As you can see, there's x here, so they can take out each other very easily. So the next thing we do, we can send this 3 to the side. That will be 7 minus 3 equals to 2 root s plus 2. So 7 minus 3 will give us 4. Just 4 equals to 2 root s plus 2. So what do we do next? We divide both sides by 2, just like under the square root of third. So 2 here 1, 2 here 2. So what do we have? We have 2 equals to root s plus 2. So we're almost there. We've almost gotten our value for x. So what do we have? This 2 equals to s plus 2 in root here. Become s plus 2 raised to power 1 over 2. Now how do we get rid of this? Just times 2 over 1 times 2 over 1. Now square root according to indices rule will become 1 over 2. The square there is 2 raised to power 1, 1 over 2 right up here. So 2 takes out 2. So 2 raised to power 2 is 4 equal to x plus 2. Send this to the other side. X is 4 minus 2 while x is 2. As simple as ABC. So if you fix in 2 right into that very equation, if you fix in your 2 plus 7, that is root 2 plus 7, which is root 9, which is 3, minus root 2 plus 2, which is root 4, which is square root of 4 is 2. So 3 minus 2 is 1. That's it, as easy as that. Okay, there's a second example. Now look at this. We are asked to solve for x in 5 root 3x plus 7 minus 2x equals to 14. Now, how do we solve for x here? How do we go about it? It's very simple. The first thing we're going to do, just like the very first question, we'll look for a way to send a part of this one to the other side. There's a left-hand side, there's a right-hand side, and this is the equality sign in between. So we can choose to send this one to this side, or we can even choose to send this to this side and send this to this side, but that will be quite complex. So in our own best interest, we have to send minus 2x to the other side. So that will be 5 root 3x plus 7 equals to minus 2x crosses. Whenever a number crosses the equality sign, the sign changes. 14 is here waiting. 14 plus 2x right here. So what do we have next? Then the next question is, how do we get rid of the root? Now, for us to get rid of the root, first of all, we can decide to divide both sides by 5. Just like this. 5 takes out 5. So we end up with 3x plus 7 equals to 14 plus 2x over 5. So you know the rule under the roots of indices, 3x plus 7 here, since this is a square root, this is square root of 3x plus 7 raised to power 1. So I have a 3x plus 7 raised to power 1. The root here is 2, that is divided by 2. So 3x plus 7 is 3x plus 7 in bracket raised to power 1 over 2 equals to 14 plus 2x over 5. So I look for a way to get rid of this. How do I do that? I'll use my multiplicative inverse. 1 over 2, the inverse of 1 over 2, multiplicative inverse is 2 over 1. So whatever I do to this, I will also do it to this to keep it an equation. So 2 over 1, 2 takes out 2, this 3x plus 7 equals to 14 plus 2x over 5 raised to power 2. So the next thing we do now is to expand this very side. We got 3x plus 7 equals to 14 plus 2x over 5, all in bracket raised to power 2. So we look for a way to expand this. So that will be 3x plus 7 equals to 14 plus 2x over 5 times this is a square, we're doing it 2 times, 14 plus 2x over 5. So we're going to multiply all the numerators and then the denominators. So that will be 3x plus 7 equals to, so we're going to do that, we're expanding. 14 times 14 is 196. 14 times 2x is 28x. Plus 2x times 14, 28x. 2s times 2s is plus 4s squared. All over 5 times 5 is 25. So what do we do next? The next thing we do is to cross multiply. This multiplies this multiplies this. So 25 times 3s plus 7 equals to 1 times 196 plus 28x plus 28x will give us 56x then plus 4x squared. So 25 times 3x will give us 75x. 25 times 7, 7 times 5, 35. 5, keep your 3. 2, 14, 17. 1 on the 5. 1 times this is 196. 1 times this is 56x. 1 times this is plus 4x squared. So we're going to collect our like terms to bring together all the set of stars that look alike. Here we have on the 5x, we have 56x, they will be brought together. 1 on the 5 and 196 will be brought together. So you just have to send them to the side. Send this here, send this here. So plus 4x squared stays out here, plus 56x minus 75x plus 196 minus 175 equals to 0. So plus 4x squared right here plus 56x minus 75x will give us minus 56 minus 75, that will give us minus 19x. Then 196 minus 175, that will give us plus 21 equals to 0. So we're looking for x, we're almost there. So we're going to be using our formula method to solve this. So a is 4, b is minus 19, c is 21. So minus b plus minus square root of discriminant b squared minus 4ac, which is the discriminant, over 2a. So what do we have? The next thing we have is minus b is minus 19, minus 19 plus or minus, b is minus 19 raised to power 2, then minus 4, a is 4, then c is 21 over 2 times a is what? A is 4 over 2 times 4. So what do we do next? So we just continue like this. We're almost home. Minus and minus is plus. 19 plus and minus. 19 raised to power 2 is minus 19 raised to power 2 minus 19 times minus 19 will give us plus 361 minus 4 times 1. 4 times 21 is 84. 84 times 4. That's 332. 336. 4 times 4 is 16. That's 336. 336 over 2 times 4 is 8. So 19 plus or minus 361 minus 336 will give us 25 over 8. So we have a perfect square there. 19 plus or minus square root of 25 is 5 over 8. So we're almost there. We're very close. So what's in there? This 19 plus 5 over 8 or 19 minus 5 over 8. So 19 plus 5 is 24 over 8. 19 minus 5 is 14 over 8. So 8 here 1, 8 here 3, 2 here 7, 2 here 4. So our x is 3 or 7 over 4. So when you look at this very well, you find out that 3 is our perfect result. If you pick your 3 up and fix it in that very equation, you will get a perfect result. So it is time for us to get ourselves tested to see how much we've gotten from today's lesson. So this is our take home. So the first question is this: solve for x in root x plus 1, x plus 11, I beg your pardon, plus root 2x minus 1 equals to 7. So we have to look for x here. So the second question: solve for x in 3 root 4x plus 1 minus 2 root 3x plus 7 equals to 5. So we have to solve for x in both and solve the equation. So at the very point in time, we're going to be drawing the curtain on today's exposition. So if you found us resourceful, please subscribe to this very channel and share this exposition. See you in the next exposition. Thanks.